This is Factory Founder Bay, where manufacturing never slows down.
Inside this massive industrial complex, nothing is here by accident. Every sound, every vibration, every moving machine is part of a system designed to turn chaos into control. What you're looking at begins with thousands of old, rusted motorcycles, once famous machines, now broken, corroded, and abandoned. Some are stacked in towering piles, frames twisted together, engines seized solid by time, paint peeled away by years of exposure. These motorcycles have reached the absolute end of their lives on the road. But here their story is far from over. The process begins the moment these machines arrive at the recycling facility. Trucks unload huge tangled heaps of motorcycles into open scrapyard zones. There is no order yet. Sport bikes crushed beneath cruisers, classic frames welded together by rust, wheels bent beyond recognition. Forklifts and cranes move carefully between the piles, lifting entire clusters of bikes at once. Rust flakes fall like dust. Oil drips from cracked engine cases. This is raw mechanical decay on an industrial scale. Once inside the intake hall, the environment changes instantly. Massive steel walls surround the chaos. Bright industrial lights expose every dent, crack, and corroded surface. Hydraulic machines push and separate the tangled piles so individual motorcycles can be processed. Each one is scanned, logged, and routed forward. Even in this condition, every machine is accounted for. Before destruction can begin, danger must be removed. Old motorcycles are filled with hazardous fluids: fuel, oil, coolant, brake fluid, battery acid, some of it decades old. Each bike is lifted onto reinforced platforms where sealed extraction systems drain every liquid safely. Oil mixed with metal particles drains slowly from seized engines. Batteries, swollen and corroded, are removed using insulated tools and locked into hazardous containers. This step is critical. Nothing moves forward until every toxic element is neutralized. Now, the real dismantling begins. Technicians and machines work together to tear these motorcycles apart, piece by piece. Wheels are ripped free. Fairings shatter as bolts snap under torque. Exhausts slide out, crushed and rusted flat. Chains are cut apart, link by link. Engines, once the heart of these machines, are hoisted out with cranes, dripping sludge as they separate from frames that have held them for decades. What remains are skeletal frames, empty and fragile, standing in racks like metal remains. Every part is evaluated. Some components are too damaged to save. Others, surprisingly, still meet structural limits and are set aside for refurbishment. But most will go further, into total destruction. This is where identity ends. Stripped frames and scrap components are fed into colossal industrial shredders. Conveyor belt twisted steel directly into rotating jaws lined with hardened blades. The sound is violent. Frames collapse instantly. Engines fracture. Metal screams as it tears apart. Sparks burst outward. Dust fills the air. Within seconds, entire motorcycles are reduced to unrecognizable fragments. What once had brand, history, and identity is now only material. From this chaos, order returns through physics. Shredded material flows onto sorting systems where magnets rip steel from the mix with invisible force. Aluminum is ejected sideways by eddy currents. Plastics and rubber are separated using sensors, air jets, and optical scanners. Each material stream moves independently now, purified by automation. No hands touch the fragments. Machines do the work faster and more accurately than any human ever could. Next comes refinement. The refined materials are then compressed, pelletized, or baled. Steel is crushed into dense blocks weighing hundreds of kilograms. Aluminum becomes uniform pellets. Plastics are packed into sealed industrial bags. Everything is labeled, logged, and prepared for transport. At this point, recycling is complete, but manufacturing has only just begun. The materials move next to foundries. Steel bales are lifted by cranes and fed into furnaces hot enough to erase history at the atomic level. The metal glows, softens, and collapses into molten pools. Rust burns away instantly. Impurities are removed. What flows out is pure liquid steel, poured into molds and cast into billets. Aluminum follows a similar path, melted, purified, and cast into new forms. As the metal cools, structure returns. Billets are reheated and fed into rolling mills, where enormous rollers flatten and stretch the metal into sheets. Sparks explode where hot steel meets hardened rollers. Water jets quench the surface, locking in strength. Steel fragments enter massive rotating drums where vibration and impact knock away rust, dirt, and contamination. Water sprays and filtration systems strip surfaces clean. Aluminum is washed separately, oil skimmed away, oxidation removed. Plastics are cleaned, dried, and shredded into uniform flakes. By the time materials exit this stage, nothing remains of their former shape. They are clean, raw resources again. Plasma cutters slice sheets into precise dimensions. Nothing here is approximate. Everything is measured, adjusted, verified. Those sheets move into stamping halls where presses weighing hundreds of tons slam down again and again, shaping recycled metal into structural components. Deep drawing operations pull steel into complex forms. Aluminum is stamped at high speed through multiple stages. The floor shakes continuously. Every hit is controlled. Every result is inspected. Then comes machining. CNC machines carve these parts down to micrometer precision. Spindles scream as tools cut through steel and aluminum. Coolant floods the cutting zone. Chips spiral away. Surfaces become smooth, exact, perfect. Holes are drilled, faces milled, contours shaped. Robots load and unload parts nonstop. Human hands no longer guide the process. Data does. Once machined, the parts are strengthened again. Heat treatment furnaces bring steel back to glowing temperatures. Parts soak under precise conditions before being quenched violently in water or oil. Steam erupts. Hardness locks in. Aluminum undergoes stress relief cycles to prevent warping. Surface finishing follows. Shot blasting, coating, curing, protecting the metal for decades of future use. But strength alone is not enough. Every component is tested to destruction. Fatigue rigs hammer parts millions of times. Thermal shock chambers freeze and reheat metal in seconds. Corrosion chambers simulate years of exposure in days. Some parts fail. Those that do are removed instantly. Survivors move on. Final corrections follow. Laser scanners map every surface. CNC machines make microscopic adjustments. Dynamic balancing machines spin components at high speed, trimming mass until vibration disappears entirely. This is perfection enforced, not assumed. At last, the components are packaged. Robotic systems secure each part in protective crates. Serial numbers, QR codes, and traceability data are permanently attached. Containers are loaded with mathematical precision. Logistics systems schedule every movement. Nothing is left to chance. In the final moments, autonomous trucks roll away from the facility. Containers move by rail, by ship, by road. Inside them is no scrap, no waste, Only certified, validated industrial components, born from motorcycles that once seemed worthless. And inside the factory, the machines never stop.